Let's now go through this example here, which says identify if an Eulerian trail or circuit exists for each of the graphs below. If one exists, describe the trail or circuit. Okay, so when you're in this situation and you want to identify whether or not you have a trail or circuit, the first thing that you want to do is label the degree of each vertex. So this has a degree of 2. This has a degree of 4. This has a degree of 2. This has a degree of 4. This has a degree of 4. And E here has a degree of 2. What do you notice about the degree of each vertex? Hopefully you notice that they're all even. And when they're all even, that means it has to be a circuit. It can't be a trail. So what we have here is an Euler circuit. Now you need to remember the definition and characteristics of an Euler circuit, all of which is listed here for us. So an Euler circuit, here it is. The Euler circuit includes every edge exactly once and starts and finishes at the same vertex. The graph must be connected, which ours is. All vertices must have an even degree, which ours is. And vertices other than the start and finish may also be repeated. So I can repeat vertices here. So with all this in mind, let's now describe our circuit. Now, there are multiple different ways of doing this, but you just need to make sure that you start and finish at the same point and that you don't go over any edge more than once. So let's just begin and end at A here, but we could have chosen any point. So A is going to be my start and it's going to be my ending point. And remember, there are multiple different ways of going about what we're about to do. You just need to make sure, as I said, that you start and end at the same point. You don't repeat any edges and you may hit the same vertex twice. All right, let's go. Let's go A to F. So I'm going from A to F. Let's go F to D. Let's go D to C. Let's go C to B. Let's go B to D. Remember, it's fine to hit the same vertex twice. Let's go D to E. Let's go E to F. Let's go F to B. Let's go B to A. And just like that, I'm done. And take note of the fact that I began at A and I ended at A. That's it. That's how you go about this question. I didn't repeat any of the edges. That's how you go about it. All right, let's now move on to the next one. So what we're going to do here to determine whether or not it's going to be a trail or a circuit is we're going to list the degree of each vertex. So this has 2. This has 1, 2, 3, 4. This has 1, 2, 3. This has 3. This has 4. This has 4. This has 2. This has 4. Immediately, what you should notice here is that I have 2 odds and the rest are even. And when we're in this situation, when we have 2 odd degrees and the rest are even, this has to be an Euler trail. Let's now remember the characteristics of an Euler trail. Let's move up here. An Euler trail includes every edge exactly once and starts and finishes at different vertices. So it starts and finishes at different vertices. The graph must be connected, which ours is. The graph must have 2 vertices with an odd degree and all the other vertices must have an even degree, which ours is. The Eulerian trail will always start and finish at the vertices with an odd degree. So we need to make sure that we start and finish with the vertices in an odd degree and the vertices may be repeated. So we need to make sure that we start and end at either C or H. It doesn't matter which one we choose. Let's just say we start here and let's say we end there, but it could be the other way around if you wanted. All right, like this one over here, there are multiple different ways of going about this, but this is easy to mess up because remember, you can only go through each edge only once. You can go through the vertex as multiple times, but each edge you can only go through only once. So you got to make sure that you don't mess it up. It is possible to mess this up. If you like, you might like to pause the video and see how you go with it. All right, so what should we do here? You have to be careful. You can't just kind of go anywhere you want. You need to think, all right, I know I need to start here and kind of get there. You need to be careful. All right, let's go. Let's start with C and let's go C, E. Then E, B. Then B, D. Then D, A. Then A, B. Then B, C. Then let's go C, H. Now, you are allowed to hit this more than once. Like, I'm not ending now. It's fine to be here at the moment. And now I'm going to go up to E. Then I'm going to go E to G. Then G to D. Then D to F. And then I can come down F to G, then G to H. So take note that it's fine to hit the vertex more than once. It's actually, you need to do that in order to do this. And then just make sure that you're starting and ending where we said. And that was, we started at odd and we ended at odd. But you do need to be careful. You can mess that up and be in a situation where you would have to repeat an edge, in which case you've messed it up and need to start again. All right, let's read C now. It says, for the graph that has no Euler circuit, so that's referring to B here, it's an Euler trail, is it possible to add one additional edge to form a circuit between the two? Now, this is a little typo that we need to fix up. Can you scribble out the word edge here and write in vertex? Vertices rather. Between which two vertices should this be added? All right, so what it's saying is, can I add an edge here such that I could now create an Euler trail? And you could. What you could do is you could link up this and that. And if you did this, this would now become 4. 1, 2, 3, 4. This would now become 4. So if you added that edge, now everything has an even degree. So now you could create an Euler trail. So let's just rub that out so we don't get confused, because later on you will want to come back and look at that. So which two vertices should this edge be added to? So what you can say here is between the two vertices with an odd degree. So if you add an edge between the two vertices with an odd degree, this will make them both even. Will make them both even. Even. And just like that, we're done. So between the two vertices with an odd degree. So as I said, if you just added a line there and there, now this becomes 4, this becomes 4 because you've added another degree, in which case they're all even, in which case you can create a circuit. All right, hopefully you found that helpful.